go through things.
Yes, tonight is 8:03, 11 of the November, Tuesday, for the another session of the MWU. We are almost on the second week of the module 1A for the mosaic and mineralogy of the moon. And we're gonna go some of on the previous session, we provided some basics of how you're gonna take a mosaic picture of the moon, 5x5 or 3x3. Mostly we focus on the prompt 5 and 6, and based on the smaller field of view, we needed to make sure that I have a grid of the 5x5 or 25 picture for each color. One for the U band is a blue color, one for O3 the green color, and one for the H alpha, that is red color. Therefore, we're gonna have 25 red, 25 green, 25 blue, total 75 pictures. And those is because we have too many pictures and each of them has a very big data. Some of the activities here, we cannot proceed at all of them in one shot, 1 hour. And probably we glance over the main concepts of the basics on this session. And you do, after the class, continue the efforts on the some of the activities that we do on the processing may take a few days, few minutes or few hours, and depended on the server speed, internet speed, and sometimes it's easier to run it on the close to midnight or after midnight that servers are low. But sometimes I also encounter problem after midnight, also some of the servers making upgrade or down. And therefore, this is kind of try and error. You have to make sure that this lengthy process of the post-processing of the picture goes in right order. Let me go over the items that he had. Make sure that I click the share sound and go. Okay. Here the one, the Word format that I sent it. This is like, it's not like OPIS that is fully developed curriculum, but this is under development. This is the latest one that I get it from Professor Dan. That is provided by August, September, a few months ago, but it is going to be followed accordingly. And later on, next year might be changed. This is a section that I glance over. When I'm sharing and I explain, I'm just sharing the Word format of the MWU to send it on a spreadsheet. You see it on the screen?
Yep, everything looks really good. And I added that newest module, I think it's the newest one, into the chat also as a download.
Very good, thank you. And also that gives some indication on the first pages to how to make a picture that we go over last week. And here, say 25, 25. If we're choosing different telescope, we choose different duration, and based on this table. And when we're done, therefore, it's gonna be pictures are ready for the what they call it, the graph that is showing here. The one that I'm gonna show it here, the one that I did it 75 picture, as you see it here, 75 out of the 75, and each of them has different one. For example, as you see it in here in the SkyNet, my SkyNet, it shows filter is U. This is 0. Start from 0, and 0 to 74. It goes down. You see 11, and then 26 and 24. Sorry. 24U, this is 0 to 24U is 25 picture of the U band, blue color, and 25 to 49 gonna be H alpha, that is red color, And if we go to the about 49, I guess it's H alpha. Let's see if I don't miss it. Yeah, here is the one. As you see it here, because all of them cannot be put it on one page, you have to click the second page. You see the second page, and when you come to the second page, you're gonna see the other band. Have to wait to computer bring it. Yeah, here is O3. This is green color. It's gonna be from 50 to 74. At the end, this is gonna be end of the 75 picture. From 0 to 74 is the 75 picture on 3 different bands of the colors. First thing we have to look through it here. Three important thing is created here. We're going to use for master calibration images. This is the basics of the astrophotography. Any camera that you use for astrophotography, you need to have this bias dark and flat images, and each of them has create a kind of different idea for the picture. And also here showing the picture what time is taking, and for example this one dark image and also flat image, different time and different age. And because each of them also different, for example this 74 is taking on this time November 7 5:16, and here neither of them is matched with this one, because these bias dark and flat are not exactly matched with single of the picture, and practically nobody can do that to make it all of them at the same time. And therefore that create a kind of issue of the error that is not major, but it's gonna we're gonna have it minimize it this different effect gradually. If you click on, let me go over just brief discuss on this one. What's that one? The dark image and bias image is almost the same thing. When it is consider bias is when it is the camera is closed, it take a picture. Therefore, you don't see any lengths here, and therefore here you don't see it any lengths here. And if you click on here, it shows you see here. This is bias image. There is a line here. This is due to the sensor inaccuracy or whatever build-up made it on the sensor of the camera. And neither of the cameras is perfect. Although it is biased and camera is closed, we expect it to have complete darkness, but we don't see it. Therefore, what we should do, we have to see close the. Let me see, where is the? Oh, we have to go back here. Here, as you see the line on the bias, it shows the inaccuracy of the defect that exists on the sensor. Therefore, we're using this bias on the astrophotography, and the program is written in the SkyNet or any other software for post-processing. It deducts this bias from the picture. It means that if, although you see the lines here, you see these lines on your astrophotography also. But when reducing this one, deduct this one from the astrophotography, your picture become closer to reality. This is one of the factors that we have to do that. Second one is the dark. Dark has a kind of 60 second. It means that they're taking the picture, but is open, but it is in a way that is 60-second duration. And on the dark region, when it is the camera is not open to the sky. Therefore, here, the one that we had it here, 60 second, if your observation is less than 60 seconds, this gives you better result. But if your observation, sometimes you needed to take a picture of the very dark nebula or faint nebula or galaxy, you may take it several hours or several days to process the stacking the data. And therefore, for most of the practical way, this 60 second that is choosing in the SkyNet is a good practice that we can use it on normal astrophotography. If you just click on that dark, you see different scenario here. You have 4 layers. Each layer has their own defects and lights, although you see it dark, but you see it different layers and lines. And this one also, when in astrophotography, when we have this one, on the picture that you're taking, you're going to see this line also if you don't process this. But when you deduct the dark image, you're going to remove all of these defects from the picture itself. And this is a second configuration or calibration. This is, we call it master calibration images. We needed to this one. This one is a flat image. If you take a picture of this, you see it, this flat image that is taken here. Normally, as you see it, in the center has very light. On some area has a darkness. On the close to the boundary has also some light. And there is a donuts, you see it because of the dust and various kind of things that is attached to the camera and the lens. Therefore, these are all artifacts that may observable on your picture. And sometimes when you take a picture from the SkyNet also, you see those, because the reason is that these, although we have bias dark and flat, and SkyNet automatically reduce processes those, but eventually yeah, some of them may not trigger it and just bypass from this configuration and calibration is show up on your picture. Therefore, this is kind of trial and error, and all the provided calibration by providing here to make sure quality of the picture is good and good way to review the things. Let me take a look to one of the pictures that we have here, taking number 66, see how it looks like. As you see it, it looks like a very good, but you know, this is a, although it is green picture O3, but you don't see it the color here. You have to assign it to an Afterglow or the color on that to see it. Therefore, whatever you see it here, it shows black and white, but is already embedded inside the color that you're gonna add on the post-processing. And similar way on the red, blue, and the others. For example, this one is looks should be blue, but you don't see it. You see it black and white in here, but pretty nice and good picture, but still needed to process to get it much better on the astrophotography. There is a few items here available here for each picture. You can download JPG, you can download FITS file, or you can download the view headers and kind of registration. If there is an error, it's going to show out here. And other basic items, explosion length 0.2 second that is taken. Okay. Here, therefore, this is the kind of basic things that you see it on this picture. Any questions so far on the this basics of the this calibration files?
Professor, so the overlap between the different types of images, it's really to reduce the different types of bias, like dark or flat, at the borders of each image, right? Not to help SkyNet match it up.
No, SkyNet gonna always SkyNet on any picture that you're taking, either planet, galaxy, or other things. Remember, let me go on the as you see it here. One thing I forgot before I answering to you, I'm gonna answering to you on Afterglow when we go to the next one, because here you cannot see it. But I wanna show it exactly what we see it here. If you click on here, you see this is a kind of flat image for the U band. And for the U band is, sorry, I just close it differently. If you go here, you have one U band flat, one for the H alpha. You see, totally those are different. And also, if you go to the, every color has different U band. Therefore, this flat is taking for each of them, because that is kind of defect that we see it on the filter and also the processing combination of the astrophotography picture itself. And each of them, they have their own nature because of the filter structure and also the path of the astrophotography. But to answering your question, let me go over here. The next step you're gonna do after you done this kind of activity, let me bring this one down. You go to the
Open
Afterglow.
Afterglow. There's a handy little button there.
Yeah. Did you do you see the Afterglow right now?
Yes, I see the Afterglow with all of the moon images on the left.
Yeah, this one is actually I take it about few hours ago, and but unfortunately it doesn't process it, and I'm gonna show you how to make it this one happen. It's for example this one, as you see it, one of them. And before we going that, let me answer your question. If you go here, when you wanna open the file, you click. Let me see. Where is the click? Yeah. Okay. Let me close this one. Okay. Here, let me go open a file. If let me see why. Yeah, here. When you go here, you go to the SkyNet robotic user observation that is for you yourself. For each of them, for example, I wanna open one of the picture that I taking. For example, here I take it Carina Nebula. As you see it here on the second layer, you have several pictures. The raw picture is the one that has no process on that. We don't normally take it this one because there is many defects, many kind of items exist on here, and therefore you cannot practical for this activity that we're doing on OPIS and MWU. We normally, as remember, I ask for do the reduce. The reduce image is the one that is come out of this raw image, and after master calibration, the master calibration image is the one that is showed the dark. Let me click in that to see what's here. You see here, this is bias, this is dark, this is flat. Therefore, and because we have one luminosity picture, only we have one flat. If we have several filter, we may see it several things here. But going back to here, when we click the reduce image, this image and click on here, all the outcome of this reduced image, because as you see it here, reduced image, is out of the calibration and automatic calibration that done by the SkyNet itself. I don't know, I answer your question or no, but this is normally those biases and dark and things automatically taken by the telescope and observatory and as a picture for the SkyNet. And at the end, it gives you reduced fits file that always we open that to look through the picture and the afterglow.
Got
I'm
it.
always I'm always amazed how the image improves. You know, you look at the raw image and you compare that to the finished image, just how those little processes really make all the difference. And a lot of artifacts disappear that you think there's something there wasn't, there's just noise. And even the slightest changes, it just really improves the image. And you know, historically, Abbas and I had both seen the CCD development. When these CCDs first came out, I remember the first ones, the first images, you couldn't tell what was in there at all from the raw image. You couldn't see nothing. The newer ones, you can actually make out what things are. You had to do the dark and all the different subtractions, and then it was like magic that there were things there in this noise that just started popping out because the noise is predictable, which is nice. Those things, those artifacts, those imperfections, and even like the grid arrangement of the CCDs is such that it's basically a matrix, and you take those matrix of basically baseline values with no image coming into it. You can just subtract that off, and that difference is really where our image is. That's a neat learning, I think, a neat step in learning that our CCD, the image we get, is really the difference between the raw and the noise, and that difference in threshold, that differentiation is actually what we see.
Yeah, thank you. And I hope this answer your questions, Ron.
Yes.
Okay, thank you. And the thing is that here we have the situation on the kind of, for example, this is the one that I take a picture of, first one. When you do that, you have on the display menu, and you have to click on the zoom to fit to make sure that comes. And because the picture is very kind of extensive, it takes time to bring it on the picture. And also sometimes it's beneficial to enlarge it here. As you see it here, this one is H alpha picture, and this one is H alpha. This is O3, and this is 48 picture. This is 49. All of them reduce. What that reduce means that already master calibration done on here. But when you look through here, this is the one that you have it here, H alpha 48, but you don't see it here. Everywhere is empty here. Only you see part of it, because this is a kind of mosaic of the picture that is taking. Then we learn how to do the post-processing on here on the process. As you see it, you can put it, click on several of them, and you bring it here and look over to see it. This is 25. This is 26. It takes time because the amount of the data on the files are big, and dependent on the accuracy of the speed of the server, it takes time. And this is 48. As you see it on the right, there is a graph of the pixel value intensity on the different temperatures of the sea in here. The one that is important here, we played with many of these numbers, like I or graphing and things like that on the previous session. But in here, we normally, let me make it this one. Sometimes you see this one and I'm clicking, it doesn't open up. Therefore, sometimes you have to play with this one. It is not very easy, and make sure that we do it again. We close this one. Okay, show this one. Close this one and open just one. Okay. The three tasks that we normally, let me do it again. That's computer went out. Okay. Share it again.
Ron, have you already downloaded your moon images to Afterglow then? Are you at that point?
I have not downloaded them yet, no.
Okay, I'll try to put mine up. I was just opening them up. It takes a while. I
Yeah,
know I
it
have,
takes, exactly. It takes a lot. You have to watch out on that.
yeah, I was like made a mistake. I had my Jupiter files up. I closed those. That took a while, and I'm still waiting for the moon ones to open up. And my internet's usually pretty fast here, but I have 1,000 windows open. That
Uh,
might be part of my problem.
I'll get to downloading these then.
Yeah, just to let you know. And it's fun to go through these process together if we can.
That's it's always fun when it tries to download into .zip.
Oh, so I just opened them up for now. I think open them into, I will
Yeah,
be
yeah,
actually downloading them also for class, but
yeah,
yeah, I
yeah.
might cancel them
And
and do it later.
in this M1A, three icon as you see it on the right side of the Afterglow, many of the activities there. First one is the display that normally we are on this page when we coming, and several of them is very important on this module. This is one of them. As you see it here, show cosmic correction, and next one is the this one. Next one is the aligner, and therefore this one we call it cosmic correction. This is like a aligner, and this is a stacker. Therefore, we're gonna come back to here to look through those very meticulously on this, how it gonna work. Let me go back to this one, the bonus video here. That also provided by Dan. It's about 8 minutes. you can look through it, and it gives you the same idea that we discussed about what the biases and darks and flats played on the calibration, master calibration. And here, let's describe it by wording, image processing, how it's going to be done. And here, just uploading the files on the media that you're going to have. And then you making some correction here. This one, first thing that you're going to do, we call it cosmic correction. Cosmic correction that I showed you, let me show it again in here. This is the first one that you see it here, cosmic correction. This cosmic correction is, you may ask that we already removed dark, we already removed the biases, we removed the flats, all the defects on the filters and the sensor and camera is gone. Are there anything left? Yes. All the cameras has cosmic defaults, bad pixels. Some of the pixel is hot, means too much bright, and some of them very cold. It means too much dark. And this kind of things create a bad, sometimes it creates a bad column. I show some pictures here. For example, as you see it here, there is sometimes you see on the picture, there is a black color, black dark line is happened. And sometimes you see it here, there is a line mixture of the dark and red, white. And also if I enlarge it here, as you see it on the right, this is after cosmic correction. But here, as you see it, this is a big star here, two small star here. But you see here, there is a dots here. This is, they call it hot pixels. And this is a star also. There is too many hot pixels here. You don't see it here. As you see it, this hot pixels that is white, after cosmic correction, gonna be removed. And this is very important for deep sky observation, and for the moon may not be very important, but it's still gonna be make it better if we do that one on the first step. Therefore, in addition of the dark bias and the flat pictures that we're taking during the astrophotography, we needed cosmic correction. This cosmic correction removes the bad pixels that is taken by the astrophotography on the picture. And this one shows the before cosmic correction. This is after. You see more smoother, and because you may, if you don't do that, you may take it. There is another star. You discover a binary star, double star here, but actually those are the bad pixels. You have to correct it. This one, otherwise, the data may not be applicable for investigation. And next step, I'm going to show it to here on the item. The cosmic correction, we have a certain set of the parameter on the cosmic correction. Neither of them is important. We're going to take whatever is chosen by the program, and we're going to continue that for the cosmic correction. Let me go over the cosmic correction here. First, we have to do it. Okay, let me do it again. It is share. Yeah, okay. Then I have it here. All the items are here. Then first thing I have to go to cosmic correction. On the cosmic correction, there is a magic icon is there. They call it this one icon. When you click this, you see here, there is neither of the select images in here. One option is that you come and select either of them. Another option is that click on this one. It takes a while, and it's going to select all of them. And you come here, then double check, make sure that all 74 pictures are selected. It means that whatever we're going to do cosmic correction, it's going to be done for all of them. And these parameters don't change it. Just leave it as it is, because this is kind of based on the experience by the SkyNet and also the expert on that astrophotography on the programming of the SkyNet. They assume this are valid for all of them. We group by filter, group by instrument, and different parameters given here for the kind of correction and calibration of the bad pixels on the picture. Therefore, the first thing we learn here that dark, bias, and flat are due to the defect on the filters, cameras, and the sensors, and various tools that is taking the picture. And here, cosmic correction is the one, the pixel, the bad and the cold and hot pixel that is created in astrophotography that is goes beyond the dark and bias and flat. We have to correct those. Therefore, this is second step on the astrophotography. After you click all of them, make sure all of them is identified and submit. When you click the submit, it takes a while. Here, you see here it shows processing the job. It shows 0%. It may takes a while to process that one. Therefore, you have to wait to make sure this already done and processes accordingly. You can open it if the permit for you here. If you open it, you see glance over. You look through the different pictures that you had here, different names, and still when it create when you do the this kind of post-processing, it gonna takes a while. Here it doesn't show immediately. Sometimes takes few minutes, sometimes 10, 20, few hours, and therefore this may lengthy process on this activity.
Professor, is there any way to do this like collectively for all 75 images?
Yeah, this is
Or
the one. Yeah, this is the one that we're doing. On the first
oh,
one, we do all of them 74, 75. You see, all of them selected here.
that's a relief. I thought we would have to
No,
do
no,
them
no, no,
individually,
no, no.
and that would be
I
like
said
240 hours.
no. You see, this is a magic. When you click on this and select all of them automatically, uh, it is a kind of you don't need it to go select all of them one by one. And when you selected this one and cosmic correction, this cosmic correction gonna be done. Bad pixel gonna go away from all of the 75.
That's
And
reassuring. That's
yeah,
reassuring. Okay.
yeah, very good. Thank you. That's a great question. Okay, I will stop this one. Let me see. I cannot stop it sometime. Let me close it this one. Okay, I will go and open it again because this is very lengthy process. Close this.
This reminds me of 3D printing. You just put the print in and hopefully it goes and walk away and come back later, right?
Yeah, yeah. And okay, let me go the next step. Next step after you done this one is complete. You're gonna do the aligning. Aligning is basically is done to make sure that all of them align it. For example, we have several pictures, one here, one here, one here, one here, different areas. This aligner helps to align all of them to match with the identified specific location on the picture and the coordinate system that you have. Therefore, for this purpose, you need to do the one that is described on the Word format. Let me make it smaller here to show it. It gives you some indication. Here is the aligning. On the next aligning, here on the cosmic correction, you have to select all 75. But on the aligning, you have to align for each mosaic mode. Therefore, align images, go to the aligner tab, third from the bottom, then select all the images by clicking select all box. Enable mosaic mode. This is again, we have all 75 have to choose them. Let me show you on the screen. I'm here, select this one, and double check here to see all of the 75 is chosen. And
So we're
then,
not doing 25 at a time for each of
no,
the
no, no.
wavelengths. We're doing all three wavelengths at the same time.
Yeah, aligning all of them same. And we're clicking here the mosaic mode. And then when the mosaic mode is available, enable rotation, enable scaling. It is about scaling. This is kind of geometrical alignment. Is this correction, cosmic correction, is more pixel correction, bad pixel, remove the bad pixel. This aligner make sure that align all the mosaics in the geometry of the picture in single image. Make sure that rotate as needed, enable scale it as needed, and therefore to do all of them accordingly. And here you have to choose future always. Therefore, remember, mode that you have to choose here is always futures. When you do the futures, you see this enable rotating and scale is going to be removed because we don't need it on the future for that purpose. And the algorithm that is provided here automatically gonna does that for us. Therefore, first thing you do here, make a mosaic mode. Come select out of this options mode future, and here there is a different algorithm exists here for different purposes. We recommended for the MWU for this 1A, we use A case. This is kind of name of the algorithm. I don't know what they call it. Why A case? Probably by the some kind of abbreviation or some kind of item that we had here. Other item that is important here to choose is this one, ratio threshold. This is a kind of ratio threshold that is provided by approximation. Either we may use 0.3 or 0.4. This is comes based on the trial and error. What you do, if you choose, for example, 0, it's gonna give a different value. If you're gonna choose 1, it's gonna be different value. The problem is that when you choose 0 or 1, either they stacking the images in a way that there is a gap between them, or it overlap them, too much overlap and too much resolution and high blurry or kind of high resolution picture happen. Therefore, normally it is recommended to use one of them, either start with 0.3 for the prompt 5, recommended to use 0.3. For others, prompt 6, we use 0.4. But the thing is that we do this one, we choose this one and the alignment. After the correction, we select the mosaic, futures, AKs, and the 0.3 or 0.4. Then we go to the stacking. And after the stacking, after the alignment is finished, when it's finished, we check it to see how it looks like. If it looks like good, therefore our choice, first error is good, first try is good. Otherwise, we just come back and change it again and redo the realigning again. Therefore, this is kind of loop process that may take several times, but normally based on the recommendation for prompt 5, it's better to choose 0.3 and prompt 6, 0.4, and others 0.4. And again, due to the changes on the telescopes and astrophotography cameras that we have, this may change during the time as well. But therefore, you have to keep in mind, this is kind of initial stage for the astrophotography to make sure all the mosaics are aligned in the geometry of the single picture. Any question?
No.
Really helps you appreciate when you see a rendered image that an astronomer has made of somewhere in space, how much work they've taken to make this happen. You know,
Exactly.
definitely takes a lot of skill.
As you see it here, this is a little bit picture that you see it on the Word format. It's kind of very old version, but many of the features exist. You specify you select all of them, mosaic and 0.3 or 0.4 AKs, and then therefore some of the images may not be aligned. And if you see it, if your picture, specifically when you're taking in the moon, is not full moon, I did it myself. There is no error because I take it the mosaic on the full moon. But when you're taking the mosaic on the not full moon, half a moon or a quarter moon, you may see it a lot of errors, cannot align. That is because some of the mosaics on the darkness, it is not part of the what to call it, the moon disk itself, and it cannot recognize which what mosaic the program SkyNet has to align. Therefore, this warning, you may see it if you have not taken the picture of the moon on the full moon. You may see many of them, 10s or 20 of those, depending on the phase of the moon, that happen. Don't worry about that, but this one is just indication that some of the part of the moon is not observable. And alignment redistribute pixel values and cannot be redone. Therefore, when we do the aligning, it's always make sure this is the two items. Two notes that is here is important. Some images may not align, resulting from cannot align image, warning for each of them. As long as these are the blank and mostly blank images, there is no problem. We will find out on the next step on the stacking how we can do that. The next item is that alignment redistribute pixels. It corrects a little bit because if you see it two stacked side by side, they may have some at the edge of the two stack mosaic side by side, it needed to be some correlation and smoothing happen. And that is automatically done by the program on the SkyNet. And when you're done, you cannot redo it again after this one happened. And this actually make it the picture more smooth and the quality of the picture better. Once this is done, all successfully aligned images will now be in the same size. The size of the entire mosaic, which original image moved and align it on the position of the mosaic that we had in here. For example, this one that shows on this picture, it gives you an indication of how that process is going to be done. And the last step is the stacking. If you go back here in the stacking, and I click on the stacking, you have to make sure the first, let me go back here. In the stacking, we have different way of the processing. On the cosmic correction and aligning, we choose all of them. But here, we align images, we are combining them in 3 mosaics for each band of the color for the 3 filters. One for the U band, one for the O3, one for the H alpha. Therefore, if, for example, the trick that we have here is that because you don't want to go every one of them, check to see the name, how much is HL alpha, and select one by one. What you do here, just type on this filter H alpha underscore click. When you do that, all of them that you see it on here is all of them is H alpha. Automatically click it. If I remove it, this one, again, you see all of them. H alpha, O3, U band, all of them. Therefore, the trick is that here you just said H alpha underscore, and then it selected all of them. Therefore, here, when you select here, it select all of them that is H alpha. Then first thing you have to do here, select on the stacking, select the H alpha. As you double check here, make sure that nothing is missed and all of them is here. Therefore, how many you're gonna have selected here?
All of them.
No, all of the H alpha, how many?
All of the H alpha, 25.
Yeah, 25, exactly.
Yeah.
On the previous, on the this one and this one, we don't need to do this one. Automatically, we just select all 75. But here we have to choose H alpha 25. And then here on the mode, always you choose the average and need all of them is none. Then make sure that all of them is none. As is identified in here on the word format. You see this one, you select all the H alpha average, none, none, none. And you have to choose this one, select
Multiplicative equalization.
equalization, adaptive equalization, and global equalization. This is kind of processing that make sure that on that band of the filter, make it all of them equal to each other. And or here I click this one as well, this one. And here also we can do work on these numbers also order. But normally, if you don't do that, you click and submit and provide the data as needed. Therefore, here, whatever is provided here, you just use it, all of them, select all of them, and make sure that is 99.9, the other 0 selected. And then click submit. And when you submit the stacking, again, it takes a few hours or few 10 minutes. And then you do the same thing for O3 and U band also. When you have all of them, you see automatically a file named stack or file is created. If you come back here, you just, instead of the H-alpha, to find it, because that might be very difficult to find if you have too many pictures, you just type it here, stack. I don't see it because I didn't able to stack it, but when you click stack, it shows the stack file on your kind of after finishing the submit up. And therefore, that's the kind of end of the stacking that make it the picture like this on the moon itself. And you can, one thing is, remember in here, you can save the final stacking in 2 ways. One, click in this one. This is only going to show the whatever on the screenshot here. Normally, it's better to do with this export image JPG to save it correctly on this consideration. And also another issue sometimes occur is when alignment algorithm ratio needs adjusting. 0.4 is just first guess. Therefore, if it is the guess too much high alignment, algorithm finds false alignment. For example, as you see it here, this is you call it flanken moon. They say they overlap each other and have not very good alignment, stacking. And if it is if it is what they call it, it's too high, it's about 1 or 0.8 or 9, it's going to happen like this. And if it is very low, it's going to be like this. It's not tying to each other, the stacks. Therefore, we have to start with 0.3 as a point guess and do it accordingly. And after that, we're going to have 3 file stack, one for the H-alpha, one for O3, one for U. And whatever trick you're going to do, you have to select all and group them all. And this is a trick I'm going to show you on the Afterglow, how you're going to do that. This is a very creative way that they created on the Afterglow to make sure that you have correct understanding of the item in the here. Let me go back to the here original, if the permit.
H-alpha.
It takes time to bring it back to pictures. No, I have to unselect this. Okay, here. If I want to select, for example, 3 of them, assume I have a stack here, a stack of the H-alpha, a stack of O3, a stack of U band, as you see it here. What you should do, you click all of them, select by this one, and then click right-click on this 3 button and group selected file. Therefore, you see here, this is a trick that you group all of them. What it means that you group H-alpha, green picture, red picture, and blue picture in one set. That's
Yes.
going to be, yeah, that's going to be like this. This is a stacked, and within the stack, there is H-alpha, O3, and U band are there. But before the stacking, they are separate. And after creating, it creates one single grouped file that is consists of each filter. And then later on, it goes to the, what to call it, the mineralogy of the moons. How are we gonna color on that one? That I will, this one, I'm gonna show you a small video that Dr. Dan provided. I think this is the best way to make sure that we have it, we see that. Do you see the,
All right. So,
do you hear the voice?
Yes, I hear.
Okay, good.
Yes.
Let me start doing that.
in Module 1A, our primary goal is to observe the moon at optical wavelengths. We're going to want to image the entire moon, and we're going to want to do so in color. And we're going to use the subtle color that we see in our image to do a little bit of prospecting, some lunar mineralogy. But let's back up a little bit and start by talking about what features we see on the moon. And in general, there are two classes of things you see on the moon, and those are craters, which it's apparent what they are in this picture, and then you have these dark splotches, and those are called the maria. Let's start with the craters. So the craters, pretty simple, caused by impacts. The maria are as well. Let's start with the craters. So space is full of all sorts of debris, small rocks, and the small ones we call meteoroids when they're in space. If they're passing through an atmosphere, like if they enter Earth's atmosphere, we call them a meteor. And if they hit the ground, if anything's left, we call it a meteorite. Now, Earth's atmosphere is great. It protects us. A lot of these small things burn up in our atmosphere. Only the big ones make it through and become meteorites. Now, on the moon, there is no atmosphere. So you go directly from meteoroid to meteorite. So here you see a meteoroid coming in, strikes the surface with a tremendous amount of kinetic energy. It's converted into heat, melting the rock. It sends shock waves down beneath that can actually kick up some geological activity over the years to come. But it melts on the surface, throws the stuff up. I was going to say up in the air, but there is no air, just up off the surface. Excuse me. And then it comes down. And some of it is thrown away from the crater. We call that ejecta, or an ejecta blanket. But a lot of it ends up right back in the crater. You can see here. So the craters aren't very deep because most of the stuff ends back up in there and melts, making a flat surface. Here's a picture of the surface of the moon. One of the biggest, most famous craters is Copernicus. You can see it there. If you look at it from the side, and we can because we've been to the moon, we've orbited the moon and taken pictures, you can see how incredibly shallow the Copernicus crater is. Now, when you have that impact and the material's being thrown out, the ejecta, it's hot, it's molten, and some of it will bead up before it lands back on the surface. And see, here are some of these beads that have been picked up by the astronauts and brought back to Earth for study. And interestingly, if you look at this one under a microscope, you see it also has an impact. And so meteoroids come in all sizes, from very big down to tiny, tiny sizes. And we call these micrometeorites, and they're striking the moon all the time. There's actually erosion on the moon. You don't think about it. With no atmosphere, no weather, why would there be erosion? Well, the erosion's caused by the micrometeorites. Slowly, they wear away the craters and new ones come. So the surface does change slowly with time. Now, this is an example of one of the smallest impacts. The biggest impacts are what are responsible for the maria. Now, these formed about 3 billion years ago. There's still a lot of big stuff floating around the solar system. The first 500 million years was really, really busy, and then it started to taper down as things were thrown into the sun or ejected out or impacted the planets. And when it impacted the moon, particularly on the Earth-facing side, the crust is a lot thinner on the Earth-facing side. those that hit the Earth-facing side, if it was big enough, it could crack all the way through the crust down to the lithosphere and melt it, and it would then burble out onto the surface. And so we can see these regions here. Now, this is a color-stretched picture of the moon. We'll learn how to do this. The moon is not just black and white. There are subtle colors, and you can play with the color saturation and bring them out. So if we look in the Maria, we tend to see two colors. Some are blue, like the Sea of Tranquility here, very blue. And that's due to titanium mixed in with the rocks. Also, you see browns like here and here. And these are lava flows. Back when it was molten, you'd have lava flows until it cooled down and resolidified. And they have a lot of iron. And so kind of reddish, brownish hues. Now, you also get the impact craters, beads of different colors. So when you have the impact and threw the material up, some of it beads up, like I said, and some of that is blue, again, due to titanium. And you can see that here. This is called wood spot, or this is wood spot. It's right next to the Aristarchus Plateau. I'll mention both. Wood spot, you see a lot of blue. This is kind of glassy beads with a lot of titanium in it. And then next to it, and often these craters, you'll see yellow, because the impact was so great, it kind of reactivated the geological activity in that area for a short period of time. And that produces yellow and black glassy deposits, such as these that the Apollo astronauts brought back. And you can see that tinge here. And you can see it in other places if you make a really good image. Now, there are different times that you can observe the moon. The phases are always changing. Again, here's the basics. You learned this in elementary school and middle school and high school. So you've been taught the phases over and over. We have Earth. Let's say the sun is over here. The moon is going around the Earth. So as viewed from the Earth, different fractions get illuminated at different times. And when you're doing mineralogy, you're going to want to observe around the full moon because then you see everything. In this case, the sun's on this side, the moon's behind us, but not completely behind, not in our shadow. That would be an eclipse, but sort of behind us, so it gets fully illuminated by the sun. You can see the whole thing. And that's good. The thing is, when the moon is in that position, you don't really have three-dimensional craters. If you really want to see craters, look at a different phase. For example, first quarter phase here. In this case, the sunlight's coming in from the side. So these moons here, these craters on the edge of the moon are being illuminated from the side, and they cast shadows. It's those shadows, that makes them look so three-dimensional. Where you can see here, this stuff that's being illuminated directly looks rather flat. So I encourage you to make your moon picture twice, one around full moon and one at some other phase other than new moon. One for mineralogy and one to check out the craters. Okay, I'm going to stop there.
Boy, he does a good job of just conveying that across and what's going on there.
That's the kind of things. Although we didn't actually color it this one, I think we get to some basics of the mineralogy that we're going to learn how to color it on 1B. But basics of that, we able to make sure that we have stacked images of the moon ready for the next week that we can go and color it in the 1B module that I'm going to share it the Word format by that time.
I like that. Okay, this is really cool.
That
and I'll try to program
yeah, that was very time consuming itself. I tried to run it since last night, and I didn't finish it the runs yet. And therefore, you may take a few days to able to finish all the steps.
Yeah, I'm letting mine run again because usually the stuff goes pretty quick. I forget, there's 75 of these to go through. Mine's still going. It's been almost an hour here. It's still kind of rolling up. So what's going to have to do with these is get them going and just letting them roll.
Yeah.
Let's get the mosaic what he's doing is pretty cool that we can do that all in Afterglow with the SkyNet stuff. There is another program called JS9 that also you could upload the fits into that probably give more control for students, or DS9 is even better. That's the one I'd use to really bring out those minerals. And I was thinking he gave us that mineral map and what the colors should be. And that'd be a neat task is try to take these three fits files, these three different layers, and put them together, false color them, and then try to adjust them with the filters. And so it actually does show true to what the minerals are supposed to look like. That'd be really, really cool. But yeah, it's
Yeah.
definitely a process.
Yeah, it is. And actually, when you do that, although this description is on the Word format is very clear, but as long as you don't go it one or several times, you don't kind of learn it. But this is kind of things I just mentioned on the email today that make sure that everybody follow the steps. And when you do activities one by one, and you learn more. And you do when you do many this activity more and more, you just uh, kept on your mind forever. And that's kind of learning tools that you probably better than me, John, for the as a teacher, that the student how they learn when they repeat the things more frequently and do the activity back to back.
Yeah, yeah, it's so true. There's so many steps to this, but like he was talking about how you can refine from point 3 to point 4, point 1 of those values. Is once you do this a few times, I'm not at the point yet, but at some point we get to the point by doing this where you kind of understand it. It becomes very natural, and that's where like Ruan, you and high schoolers have an advantage of being younger. I think you're quicker quite often to pick this stuff up, and just you'll know how to cycle through very quickly. Or if something's going and isn't going right, you'll know how to take some short steps. I was even thinking a person really knew how to do this. You could take clusters of those moon shots and not do the whole thing and save yourself a lot of time. Just focus on one part of the moon and just do that to do it quickly if you wanted to get the process down. But
Yeah. Okay.
yeah, I'm gonna be stealing a lot of this from my classroom in the future, so it's fun going
Very
through
good.
this. But
Very good.
I'm just glad to do it here too to really learn
Yeah.
how to do it.
One question: do you have the credit in your SkyNet available based on the you requested? I think I assigned it
Oh,
for you, but
yeah,
I'm not sure. Did you check
I
it or no?
I did. I didn't quite get that all figured out yet. I'm still working on that. Got kind of
Oh,
busy end of last week. We lost
okay.
internet at school,
Oh
so
my goodness, why?
we don't know. It might be AI taking over the world. I don't know. Just testing this out. But our systems were down a few times last week, which was kind of fun. Teaching old school and not using the computers was
That's right.
remind ourselves how we do it. How do you teach? We get kind of reliant on the online systems,
Very
but
good, very good, very
it
good.
should be up now. I hope. I'm hoping. You know, hey, the government shutdown's over. Hopefully, so I mean, all that stuff.
Yes.
Yeah,
So
yeah.
hopefully the world goes
Actually,
back to a little bit of normalcy here this next couple of weeks before Thanksgiving comes.
yeah. Thank you. And do you have any question, Ruan?
No.
Okay, good. Therefore, I think we're ending the session tonight, but for tomorrow, that